this part we're investigating the effect of enzyme activity. So we're looking at amylase, our enzyme, and then we're looking at how it breaks down starch using iodine. In this investigation then, we're going to see how temperature affects the rate of enzyme activity. So our independent variable is going to be temperature. We're going to be changing the temperature from 20, 30, 40, 50, 60 and 70 degrees. Then our dependent variable, we're going to measure the colour change. Okay, we're going to measure the colour change of our iodine solution. What colour does it turn? Then our control variables, then we're going to use the same amount of starch solution and the same amount of amylase solution. And how we're going to control it, we're going to use measuring cylinders to measure to which we get the exact amount each time. With this prac, there are going to be risks to it. As we're changing temperature, obviously we're going to get 7 degrees temperature, we're going to have quite hot water, so the hazard then obviously we can burn ourselves. So control measures, we need to make sure that we're really careful when we're using the water baths at those high temperatures. Another one then, our amylase solution is an irritant, so make sure we're being really careful when we're pouring it into our measuring cylinders. And if we do by chance happen to get any on our hands, go wash your hands immediately after. So the first thing I need to do in my investigation, I need to pour 10 centimetre cubed of my starch solution into a measuring cylinder. And then I need to pour 2 centimetre cubed of my amylase solution into another measuring cylinder. Oh, stinks. And then I'm going to pour them into a test tube. So there's my amylase, and it's going to go into our first temperature of 20 degrees. So we've got just tap water, which is 20 degrees, and they're going to sit in there for 3 minutes. So I'm going to stopwatch. While I'm doing that, I am just going to pour my iodine solution ready into one of the pipettes. Okay, so I'm going to pour some in there, and then each time then we're going to add our solution. So after the 3 minutes are up, we need to then mix our solutions together, so our starch solution and our iodine solution, so amylase solution. So I'm just going to pour my amylase into my starch solution. I'm just going to give it a bit of a shake just to make sure it's all mixed in. Okay. Then what I need to do immediately, I need to get some of my solution and I need to add a few drops into my first iodine. Then I have to start the stopwatch, and every minute for the next 5 minutes I'm going to add drops into each of my iodine. Then I'm going to record down my colour change. So immediately after, my iodine turned from blue black. And if you know what the colour change on the food test tells us, is that it means there is still starch present. The starch hasn't been broken down. What you would do then, you would need to repeat your experiment for 30 degrees, 40, 50, 60, 70, and you'll see the effect temperature has on the enzymes. Inaccuracies of the experiment would be, it's actually really hard to see the colour change when you're deciding, is it black, is it blue, has it actually changed colour and by how much. So to get over that and to improve it, we would use a colour remitter. Okay, what you would see and hope is that as the temperature increases, that you would then get no colour change because the starch is broken down until you reach about 40-50 degrees where enzymes become denatured, and there you would see the colour change, that starch remains because enzymes have become denatured.